All right, everybody, welcome to today's expert talk. Today, we're going to be talking about network best practices and taking a deep dive into the Azure services for both creating a Azure network as well as connecting into other networks for a hybrid environment. So, hopefully, everybody's ready to go. This one's got a lot of information that hopefully you can take out of this with some great thoughts and concepts that you can take into architecting your Azure environment. My name is Dwayne Natwick. I am a senior cloud training architect at Agility, which is the company that runs the Skill Me Up platform. I am a CISSP, a PMP. I also hold multiple Microsoft certifications for solution architect expert, administrator associate, security engineer associate, and multiple others. I am also a Microsoft certified trainer and a regional lead. I am active on social media, and you feel free to contact and connect with me at any of the links provided on this slide. So what are we going to talk about today? We're going to start out by building some foundational topics here around the challenges and practices for architecting in Azure. We'll talk about availability and scalability services in Azure, and then that's all going to move right into the networking services. And we're going to talk deep around the different services, both identity and access, which isn't necessarily a networking service, but it's important to all of the network architecture and how you plan and build your network. And then we're going to go deeper into your perimeter security services and then network security and monitoring services as well. And we're going to take that information and then build into the network architectures and how we architect for hybrid cloud environments, and finish up then talking about best practices for enterprise networking and talk through a couple different scenarios. And if we have time at the end of the session, we'll jump into the Azure portal and and I'll show a couple exercises around how simple it is just to start building out a network infrastructure within the Azure environment. So we're going to set the foundation here by going through some challenges an organization faces around creating that network architecture. And the key around those are thinking about what are the threats to an organization and what we need to do around our network and to secure our network. This, takes into account both our internal and external threats. And those internal threats are obviously those that come from inside of our organization, where external threats are the bad actors that are attempting to access our organization from the outside. They both play a very key and pivotal role, and some of those threats of the internal side can create external threats and vulnerabilities as well. And the ability to identify and address both of these threats decrease the risk upon the organization. Which, if we do put our creative vulnerability and that risk is exploited, we have the potential to leave data exposed and compromised and even lost, and that has a financial impact, as well as if it's a public company with regulatory standards, you leave yourself up for potential fines as well as reputational damage. So properly taking into account a lot of these, especially around your network architecture and how you're architecting that network, particularly for for elevated privileges and perimeter threats, and shadow IT is a key one, and avoiding those from leaking into your environment helps to remediate and limit the potential exposure for these external threats, such as IP identity spoofing or injection attacks and denial of service attacks within your environment. The key thing around controlling those internal and external threats is building your security posture. And the security posture is building a defense in depth strategy of multiple layers of protection within your environment. And we'll talk deeper around a few of these in a moment, but the key thing to look at here is we're trying to maintain from a organization standpoint, we need to protect our data, and that's not just our financial information. It's user data, it's employee information. All of that data is at the center of what we're trying to protect, and we have multiple layers that can help build that defense in depth strategy. If we only had one layer here for a bad actor to get access to the environment, could be fairly easy, but the more layers that we build in here, the more protection that we have, and less potential for a hacker to continue to try and find their way in. It's if anybody has ever seen the movie Die Hard, if you think about the safe that they're trying to penetrate to gain access to within that movie, there are multiple layers, and they're gating through each layer that they're going through, and it's a tedious process in how they're getting into that safe. That's what we're trying to do. We need to think about our data as the information that we have in our safe, and how are we going to put multiple layers around it to protect it. Physical security, when we're talking about the cloud and Azure environment, Microsoft takes care of that in that environment. But that's building, and that's uh, the fencing and the isolation of the data center, and video cameras, and card access, and all of those things, as well as the physical equipment that's within that data center. You have to protect that yourself when you have your own data center, but Microsoft takes all of that. Then we have our identity and perimeter and network security as we get to compute services and applications. What we're going to talk about mainly within the context of this presentation is these three here beyond physical security. And that's the first three layers are really identity and access, perimeter security, and network security. And those three layers are what we need to take into account when we're planning and defining our network architecture. A key thing as you move into cloud services to take into account and understand is the responsibility model within the cloud as well. And we'll talk about different services within the cloud as we talk about the network services within Azure. But when you look across the different services of, as I was saying previously about the on-premise data centers, you are required as the organization to provide the physical host services, the physical services of the host, the network, data center, building protection. All of those things are your responsibility. When you start moving into Azure, they take on that responsibility no matter what the service is. And we have the three different services. And if you aren't familiar with them, and the acronyms, it's infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service would be best defined as a virtual machine, and standing up a virtual machine as you would creating a virtual machine in a VMware on-premise type environment. And you have the most control as well as the most responsibility around that, because you need to manage and maintain the operating system on there. And you can see here when we talk about networks, all of the network controls are really your responsibility. And a lot of those network controls within Azure are services that you can turn on. So Microsoft, even though they don't take they aren't giving, aren't saying that they're responsible for it, there are services that you can turn on within the Azure environment to manage and to monitor those resources and maintain it within that entire Azure ecosystem. And as you move across, you can see with platform services, more of that is taken on or shared with Microsoft and in the Azure environment. With platform services, you no longer are concerned with patching and updates on operating systems or making sure that your operating system is the most current operating system. That is now being taken on by by Azure within the Azure environment, and there are some shared controls around the networking and the applications and the identity and directory infrastructure that you don't have as granular control over. Microsoft is now building some of that intrinsically into those platform services, but there's also some different levers here and there that you have to turn on different services or subscribe to advanced services to get to have those advanced controls within there. And then when we get to software as a service, which would be like Microsoft 365, now we're just controlling the data and the identities and the information that is being controlled. The users and the data is now what we as a customer have a responsibility for. It's no longer the networking and everything. You are generally going to make web access into those services rather than having to define how you get into those services and how you control those services. And so, what influences the factors around our architecture? And the key thing around there is this tug of war that we have around the users in the organization. The users want access to files, access to applications. They want to be able to be connected to all of that when they need to be connected to that. When the organization wants to meet the user requirements, but they also need to maintain the level of secure access and make sure that everything is secure and that confidentiality and integrity and compliance and all of those things are taken care of. So keeping a balance between that to maintain a strong user environment, make sure users are happy with how the environment is, how available and accessible the applications and information that they're trying to get to is really what we need to do as an organization in how we architect our infrastructure and how we architect our network. We want to make sure that it's available fast, it's available securely, and we are maintaining the compliance requirements and integrity of our information. So when accessing those resources then within the cloud, the availability of that data and those applications is extremely important, and particularly to the users. And they, like I was saying in the previous slide, they want that flexibility to access from multiple sources, and within and outside of the organizational infrastructure. But the organization must protect from unauthorized access to data. And we'll talk about many of those services as we go through this presentation. And the network controls that are in place must be architected to protect that data and maintain that accessibility to the users as needed. And that's what we'll address as we go through here. So around that whole availability of resources and availability of services, how do we build that network availability and scalability? And we're going to talk about a couple concepts here that are specific to infrastructure as a service, but are very important to how we're going to architect our environment for our applications as we build our network and talk more about the network services around it. To understand availability of resources, it's important to, from a networking aspect, to know that you have to have availability and scalability of your resources over your network. And we'll discuss this and how to control this availability and balance resources as we get into the services in a bit. But as you architect your network and infrastructure within Azure, the ability to create high availability within your infrastructure and leverage the availability or the ability to scale resources quickly are the differentiating factors and benefits of the Azure environment versus an on-premise infrastructure. When we're talking about infrastructure as a service and virtual machines, they can be scaled out quickly and on demand as demand increases, and then also automated to decrease as they're no longer required. And if your organization requires a 24/7 access to applications, then and you don't have high availability built into your environment, then revenue could be lost due to unscheduled updates in the Azure data center, for example. And this makes it important to architect these virtual machines also for high availability. And as I stated, this is really around an infrastructure as a service or IaaS type environment, because when you're running applications in a platform service, that scalability and availability of services are built in and have a high level of availability already that are part of those services. So you need to but if you're building and have to build your application in an infrastructure as a service type environment, you need to take scalability and availability into account. Or if the platform service doesn't meet your needs and you need to build virtual machines, you can do that within the services we're going to discuss in a moment. And those two services in that concept are virtual machine scale sets and virtual machine availability sets. So let's talk about virtual machine scale sets to start with. And these are exactly that. Both of these are pretty self-explanatory from a standpoint of the naming convention. They are virtual machines that run an application and can scale out and scale in as needed. And when we talk about scaling out, what we're talking about, there are two different concepts within directions that you can scale within the Azure environment. There's scaling up and scaling down, which is generally increasing the size of a virtual machine or decreasing the size of a virtual machine, or changing, increasing a subscription level or decreasing a subscription level for when we're talking about like app services and things like that. And then there's scaling in and scaling out, which is adding or decreasing resources. So duplicating virtual machines or decreasing virtual machines is what scaling in and scaling out are. So that's what we're talking about when we're talking about a scale set. We're talking about a dynamic aspect around this. And the key benefit is that when you use these resources, you're only paying for the resources that are required for the capacity at that time. So if you have to scale out and add a virtual machine for that day, you're now running, you started at one virtual machine, you're now running two virtual machines. You're paying for those two virtual machines while they're running. But if you scale back into one virtual machine, you're back to paying for one virtual machine. And if we think about this from running a e-commerce website on a virtual machine scale set. And we think about it in an on-premise aspect where you may have built a server for your website that runs at 25% of capacity for 8 months out of the year, but that increases and spikes to maximum capacity as the Christmas season starts, because your need for resources dramatically increase. Now, when you've built that server and you have made the purchase in the hardware, you have to take into account what that maximum capacity is and buy the server that is required to meet that maximum capacity. Therefore, you're wasting 75% of capacity or 75% of the cost of that server for 8 months of the year. What scale sets do is they add the virtual machines as they're required, as I was saying before. And it can be done as an automated process within the Azure environment with rules to scale in and scale out based on the current needs. Based on CPU utilization, it can increase and decrease based on rules that you have created and conditions that will add those virtual machines as needed and decrease them when they are no longer needed. And as I said, they only then pay for the virtual machine that is that are running, and it saves you then costs and allows you to budget for the 25% utilization 8 months out of the year and the spike of utilization during the Christmas season, which you'll have extended revenue based on that traffic that then helps to increase your, pay for that additional budgeted cost that you have within the Azure environment for those particular months. The other concept I want to talk about is the availability sets. And again, when building a highly available 24/7 type environment, availability sets are very important. Availability sets take into account potential unscheduled outages. If Microsoft does have scheduled outages, they do a good job usually of moving your virtual machine to another host, so you do not see downtime. But there are times when there are unscheduled updates, or there may be a piece of hardware or equipment that goes down on a rack within the Azure data center, and that's where availability sets come into play. There are two different areas that you configure your availability sets, and those are fault domains and update domains. And fault domains are exactly that. They protect you against a fault on a rack by spreading your virtual machines across multiple racks. And that can be up to 3 racks. If you are taking that a step further, and we're talking about availability zones, which are multiple buildings within an Azure region, then you can actually have those racks in different buildings as well. But let's think of it, just for simplicity's sake, from a concept of a single data center. And you can have your servers spread across multiple racks within that data center using the fault domains and up to 3 fault domains. And then the update domains are the hosts that are on those racks, the physical host hardware that your server is running on. Then are those update domains. And Microsoft's never going to do updates broadly across every one of their hosts. So to make sure that you don't go down, you spread your servers and your virtual machines across the different hosts by utilizing update domains. And you can have up to 20 servers running across those 20 update domains, so 20 different hosts. Now keep into account that you're paying for the number of virtual machines that are part of that availability set. So in this scenario here, you can see I'm showing in the graphic 3 fault domains being used. I have 4 servers on 3 racks. So I am using 4 update domains over 3 fault domains, and those are now 4 servers that I'm paying for in terms of my configuration. So those are what you need to take into account when you're building that availability set. What level of availability am I needing for my environment, and what am I willing to pay for? What is in my budget to maintain high availability of my application versus the potential of them of those servers to go down. The concept then of utilizing update domains and fault domains together is a capability then as well. So you can leverage both of these types of architectures and services within the Azure environment to give you a highly available application that also scales based on use. So as we look at, okay, I have a 24/7 application that needs to be available all the time, but when I'm running at a lower capacity, it's not as mission critical to to have 5, 6, 10 servers running. That's not within my budget. That's too costly. But I want to make sure that if I do have expanded capacity needs, that I can then add additional virtual machines to handle that capacity. And I want those spread across different update domains and different fault domains. You can set your virtual machine scale set to put those virtual machines in availability sets in different fault domains and update domains equally as they turn on, so that they don't all end up within one fault domain, where if there is an unscheduled outage of a power unit, a power distributor unit, a PDU on that rack that needs to be replaced, or a switch goes down, that I lose my entire application. It can be spread about, and then you can maintain that capacity and that availability to your customers as well as your users. And if we take that a step further, we're talking about the services that are running and your virtual machines that are running within the Azure environment. But what are we doing from a business continuity standpoint in availability? And how are we maintaining business continuity in terms of a outage or a corruption or mistaken removal of a virtual machine, or a down data center, for example? And to understand those concepts, we need to talk about replication, backup, and recovery. And Microsoft Azure has those built in and those services available to you within their environment. And the main thing around those is, when we're talking about replication, is to understand each of these concepts. And with replication, what we're talking about is just duplication of services across hardware. And it's very similar to even when we were talking about the availability sets and the scale sets, is that they are replicating those applications across multiple virtual machines. And storage replication works very similarly, where the data storage of the Azure environment is built in and replicated at multiple levels. At a minimum, your object or file within a storage account has a minimum of 3 copies that are replicated across 3 storage arrays. So if a storage array goes down, you still have 2 copies that are maintained. And this can also be increased if you use the global replication service as well, where it increases it then to 6. The main concern, though, with replication is that there is nothing more than a copy of the most recent version. So if that object becomes corrupt or deleted accidentally, it is then corrupt or removed from all of your replications. So For protection against an accidental deletion, there is a soft delete function, which is very similar to a recycle bin, to be able to recover those objects that are accidentally deleted, but it does not protect against corruption. This is where we need to think about and build into our architecture a backup solution. And Azure Backup is what is utilized for that, to maintain and provide those point in time recovery points and save those services, both from a virtual machine standpoint, a database standpoint, as well as a file standpoint within the Azure environment. And Azure Backup can be used as well as a backup resource for on-premise resources, and that expands that business continuity of your entire infrastructure. Azure Backup can also then, like I said, protect against corruption of objects and resources by allowing you to recover that information from the last save point in time. Now, this within the Azure environment for backup is a manual process of recovery. You need to know that that file has been corrupt or that virtual machine has been corrupt through if a file's been corrupt, it's generally you're going to be notified by a user trying to access that file. If it's a virtual machine, you have ability within Azure Monitor to monitor those resources and see if something goes offline and that you need to recover it. If you're requiring an automated recovery of resources, then Azure Site Recovery can then be deployed. And that is a full service disaster recovery that's capable of recovering Azure to Azure resources and applications, or on-premise to Azure recovery as well. So it's very helpful it creates a warm recovery site for you at a very cost-effective solution. The last piece around availability and the security and replication of data that's very important to consider within architecting your network is the protection of that data. And within Azure, Microsoft encrypts all data at rest by default through all of their areas of data storage. But it is your responsibility to maintain the protection of this data as it is in transit through utilizing transmission protocols such as TLS. And an example of this is establishing a policy within the organization to only transmit over HTTPS protocols when sending information over the internet. And that's your responsibility through the network architecture to enforce that policy and create that policy within the environment. And we'll talk more about policies here when we talk about monitoring and management services. When handling the keys for encryption, then the default setting within the Azure environment is that they're Azure managed keys, and they're part of the properties that are within the Azure services. But if you want separation of duties, then the Azure Key Vault service can be used, and that provides a more of an ability as an organization to manage your own keys, but still maintaining it within the Azure services, so that you're still managing that all within the portal. And in addition to managing encryption keys, the Azure Key Vault can also then help for the renewal of web certificates for your web domains, so that you don't have to set reminders to renew your certificates, so that people visiting your website don't get the warnings that this is an unregistered site or potentially unsafe site and things like that, as well as passwords and secrets that are needed for other services within Azure that need access to resources. So there, service principals and things like that. We're not going to get deep into a lot of that, but just to understand that if you need separation of duties in terms of management of keys, Azure Key Vault is how that would be done. So now that we've kind of given some foundation around the what needs to be taken into account in terms of scalability, availability, protection of information. Now let's go deep into the actual services within Azure and what we need to think about, and what services we may need as we begin to build out and architect and design our infrastructure, our network infrastructure. As I stated when we were talking about our defense in depth strategy, a key point to think about is identity and access. And this is not directly a network infrastructure component, but when we're thinking about and taking into account all of the of what needs to be done within the environment and who needs access to what. That's where identity and access really comes into play. And more, identity and access is becoming our foundational point of security within the environment and what's going to protect us overall within a cloud infrastructure. And what do we think about in terms of identity management? And what is important about identity management is it's the proper configuration for users, groups, and resources, and based on their roles to decrease the vulnerabilities of our network and avoid data from being exposed to someone that's unauthorized to have access to that network and view that data. Role-based access controls within Azure are handled through Azure Active Directory. But we also have within our on-premise environment potentially a Active Directory domain service. We may have other identities that are federated services or other business-to-business type services like LinkedIn or our Microsoft accounts, and we need to provide definition within the levels of access for all of those to resources within Azure and the data that needs to be viewed and what networks those individuals and users and groups and service and resources all have access to. Um, as we talk more about some of these services, we start thinking about multi-factor authentication and how that additional level of verification should be a foundational best practice within your organization. If you're doing any auditing of your environment within Azure Advisor or Azure Security Center, the first thing that generally comes up within that environment is whether multi-factor authentication is enabled for your users, particularly around those with administrative privileges. And that is because really, as an organization, you should have multi-factor authentication utilized. As a consumer and a customer, you should have that as well. We'll talk a little bit in a couple slides around conditional access, and this is another way to create additional layer of protection, particularly for users that are accessing information from different networks outside of your organizational network. Then privileged identity management also provides the capability for elevating privileges on a short-term level rather than giving everybody permanent administrative rights. And then overall, to summarize all this, maintaining that strong identity practice, including auditing and monitoring this, and who is accessing the network, protects the overall integrity and confidentiality of users and data. And when moving into Microsoft 365 services or Azure services. You move to Microsoft's Cloud Identity Services, I stated in the previous slide, which is Azure Active Directory. And Azure AD is not what you may know as Active Directory within an on-premise environment, which is Active Directory Domain Services, and where ADDS has a wide range of capabilities for managing domains and users and group policies and forests, etc. Azure AD is strictly an identity service for managing the users, groups, and your primary domain presence. So that's where it's a much thinner identity service directory service than ADDS is, if you're familiar with that. But in a hybrid scenario, it's important to have the users and groups and domains synchronized between Azure AD and ADDS servers on premise. And you can utilize Azure Active Directory Connect as an application that is loaded on your Active Directory domain service servers on premise, and then synchronizes that identity with Azure Active Directory to allow users to utilize those same credentials. And when defining those users and group levels of the and the levels of authorization, we then need to think of our role-based access controls and who should have access to what. And we need to think about the principle of least privilege at that point, where we are being sure that users only have access to the resources that are required for them to complete the tasks related to their job. So all of this then relates to how those users then are going to gain access to the network. So you need to think about how this is all going to be designed, who the users are within your network, where they're going to access information, and what information they need to access through the network. To take that a step further, we then have within the premium Azure Active Directory subscriptions is the conditional access policies. And what these do is provide that additional layer of identity protection for particularly remote users and users that are not always accessing the network from within your organizational walls. And this is very important right now with work from home, with many people within the organizations. Many organizations have gone 100% work from home, not many people working in the office. How are we protecting those resources? So we can do that by creating conditions based on who the user is, where their location is, what device they're accessing from, what applications they're trying to access, or just whether there's a real-time risk based on a potential threat that's out there that's known through the Microsoft threat database as a potential IP range that is compromised within the overall global infrastructure. And then we can put certain rules based on those conditions on what we're going to do. And those conditions are to allow access, which is not recommended, because if you have set a condition to flag a particular location or device and then you allow access anyway, you're really not maintaining any type of integrity within your environment or any kind of protection. So the recommendation is to either block access or require multi-factor authentication. And as I stated before, multi-factor authentication as an organization should probably be enabled across the board. So anybody that's trying to log in should be required to use multi-factor authentication. If that is something that you have a difficult time getting your user environment to embrace, then you could build these conditional access policies to then require that multi-factor authentication instead, where you then have only when a certain risk condition is triggered do you require that multi-factor authentication to gain access to the network and the apps and data that they need. So let's start to get into the network pieces and components that we're building our architecture with. And primarily around the Azure environment, we're talking about that perimeter security and what goes into building out our secure perimeter for our network. When architecting a network in Azure, what we start with and is the virtual network, or VNet. So I'll continue to reference it as VNet from this point forward, but that's the virtual network. And that's the building block that all of the services run on. It is that component, and each individual network can be used then to segment resources and services. If you're familiar with building VLANs on a switch, a VLAN for a particular application, for your IP phone system, and those type of things, a VNet is very similar to this. Each VNet has its own network address, IP address schema, and subnet. And within the Azure environment, to be able to have the different VNets communicate, it's very easy to peer those to each other for inter VNet communication, and the ability for resources to do that. But what you want to do is have your different workloads and different services on their own VNet, and therefore you can then create layers of protection, and again, avoid the attack surface for a bad actor to be able to access that environment. Key note here when peering a virtual network, and we'll show this when we get to demoing creating a VNet, is that VNets cannot have overlapping IP addresses to be able to peer them. They have to not overlap. It's very easy within the Azure environment to avoid overlapping if you're using default IP address settings when setting up your VNets. It actually will create your VNets in sequence to avoid overlapping. But if you have your own IP schema that you need to build within Azure, you need to make sure that that schema has nothing overlapping if you need to connect and peer virtual networks to have access to resources. If you have overlapping IP addresses, then you would have to actually create a gateway between both of those VNets to have them communicate, which then adds additional cost to your network. Network security groups are established as part of every VNet and virtual NIC within the Azure environment. These NSGs provide a free rule-based access control environment, very similar to rules that you would see on a firewall, but they don't provide what a firewall would provide in terms of deep packet inspection and those type of things. It's strictly inbound and outbound rules. And you have the ability then to create those custom rules to allow or deny certain traffic from certain IP addresses or ports within the environment. So it provides a very rich layer of free access control within your environment. And VNets and network security groups both have, as I said, are free within the Azure environment. So you can build these within your architecture and utilize these without any cost that are in part of those. So if you have a very thin network, small type of network, definitely not from an enterprise standpoint, but you could get yourself started on the Azure environment very quickly and easily just using these two components for network creation and security rules without building a whole lot of cost besides just bandwidth transmission costs. And then the last piece on here is very similar to a network security group, and that's the application security group. And those are rules specific to application routing. So typically, they're IP rules or HTTP type rules specific to a application, but they work very similarly. They're inbound and outbound allow and deny type rules and access control rules. And as we take it a step further, now we're talking about the extended network services that then, from an enterprise level, provide that connection and protect those connections at a deeper level. First of those is the virtual network gateways, which are utilized to create those secure tunnels to on-premise networks, as well as they can provide secure endpoints for routing to VNets. Like I said, if you have overlapping IP addresses for VNets on your subscription, you may need to use a network gateway. If you have the if you have to connect to VNets that are in two different subscriptions, then you also need to create a virtual network gateway and those type of things. But they are good for those site to site as well as point to site type capability, and you have the ability to have static policy based routing, or the most common is the dynamic route based routing. Azure firewalls are a great service as they're highly available and scalable. They're next generation firewall that provide that network traffic filtering and threat intelligence that protects your network. It's very rich and very similar to a firewall that you're going to have from Cisco or Fortinet or Palo Alto on your on-premise network, and it can be used and has capabilities to utilize that firewall connection between that and an on-premise appliance as well. Again, when utilizing the Azure firewall, it's got built-in high availability and utilizes the availability zones within the Azure regions to maintain connectivity. So definitely, very unlimited capabilities and unrestricted scalability as well. So from a standpoint of maintaining the connection between your on-premise environment and the Azure environment, and Azure Firewall can provide you with both that scalability of traffic as well as the protection and availability of that. And then web application firewalls protect against those application level attacks and DNS type attacks, such as SQL injection or an HTTP attack that might happen within your environment. And this is just another layer. It's generally utilized in conjunction with a network firewall to provide that application level of protection as well. Now, as we slide to other services within the Azure environment, we talked about scalability and availability a little while ago. And when we're talking about those availability sets and those scale sets, we have now multiple virtual machines running in our environment. So, what do we do in terms of traffic for those and controlling traffic to those servers that are multiple servers running that application? And that is where the services on this slide come into play and come into account. They not only provide the balancing of traffic, incoming traffic to your services, to your virtual machines or your application services, and they also provide a layer of security and a layer of network filtering to your environment. And by saying that, what I mean is that these services have the exposure to the public with a public IP address, where contrast to needing to put and expose a public IP address to your virtual machine, to your group of virtual machines or your group of databases and those type of things. You can protect those virtual machines by only giving them internal VNet IP addresses, and having this one of the, whatever device you're picking and choosing in your architecture, this one device is now the only thing that it has a public IP address. This decreases your attack surface because these devices don't have an operating system that they're running. So therefore, if somebody was able to compromise it by trying to get into its public IP address, there is nothing that they're going to gain access to, and there's nothing that they're going to be able to find their way to at that point. So, to discuss each of these a little bit further, we'll talk our way up through this slide here, where we're talking about first and foremost the load balancer. And load balancers are typically utilized both from an internal and external standpoint for virtual machines. They can be used also for databases, where they are part of they are that external gatekeeper where somebody, use an example of a web application, somebody's coming in through your website, they hit that load balancer and it's sent to one of the servers within that scale set. You have 3 servers running. It's going to round robin each of those, and it's going to make sure and do a health check on those servers to make sure that they are up and accessible, that they're available and not offline before routing that traffic as well, so that the user does not get an unavailable 404 error. They are getting their environment and accessing their environment, that server, and getting an immediate response to your website, giving them a good customer experience. These only work at the transport layer protocol, so it's strictly a TCP type connection. When we move further up here, application gateway does a very similar thing as the load balancer, but it does it at the application layer. So it's working at the web and internet type layer. It again can be used on the back end of virtual machines and virtual machine scale sets, but it then also can be utilized for app services. So if you are utilizing an app service for your web app as a platform service rather than a infrastructure service like a virtual machine, you can utilize the application gateway. Again, those are internal and external as well. The scenario where like a internal load balancer would be used would be to balance. You have a web e-commerce site that has your inventory on a database on the back end, and you can have your external load balancer that is being utilized to route traffic to the website application running on your virtual machines, and then you have an internal load balancer then that is going from those virtual machines, and it's balancing traffic across multiple databases as well for the inventory. So therefore, it's again limiting the level of exposure of your databases and virtual machines to the users, to the public, and to potential attacks, as well as then protecting, as well as giving a good customer experience where it's balancing traffic so that not one server or database is hit by all of the requests and then causing a decrease in performance. The last one to talk about on this slide is the traffic manager, and its accompanying Azure Front Door is part of that as well. Both of these services work at a DNS level, and they are more of a DNS resolver, where they are taking the services and identifying where that access is is being where access is from a location standpoint is being requested, and it's routing it to the closest endpoint to their location. It's very similar to what you would think of a content delivery network or CDN network would be. Think about like a Netflix where you're accessing your uh, your your movies and you're trying to stream a show on Netflix and you access that. What Netflix is doing on the back end is identifying where you're accessing from, and it's routing you to the data center closest to you, so that you get the decreased latency in what you're accessing. So that's what you need to think about there when you're thinking about a traffic manager. Is very similar to that. And where you would potentially use that is if you have a global application that you have running in multiple regions and accessing by people around the world. That would be where you would want to utilize a traffic manager, so it gets routed to the region that's closest to them. So that covers overall a lot of the services that we would be building into our Azure architecture and why we would build those architectures. But now, how do we protect those? And what pieces and capabilities do we have within the Azure environment now for securing our network and protecting our network? And that's what we're going to talk about on the next slides. So how do we help to protect our environment and network traffic uh, within the Azure environment, and as well as a on-premise hybrid type environment as well? The primary piece around all of this is Azure Monitor, and it's one of what I would think the most important services within the Azure ecosystem to monitor services. It has the ability to utilize and collect diagnostic and activity log information from Azure resources when you enable it, as well as you have the ability to deploy agents to collect that information at an on-premises level. And then on top of that, there is Network Watcher, which can watch the entire infrastructure, not just the Azure environment, but also can be utilized for on-premise to make sure that all of your connections and the health of your connections are there, that you aren't exposing ports and information. That there is no that there is not a vulnerability within your environment. And then you have the ability then to take that a step further and take that information that's being gathered and utilize log analytics and application insights to perform queries on that information, and then automate alerts and actions based on what those queries, what comes back in terms of data from those queries, in terms of suspicious activity or potentially down connections and things like that. And we talked a little bit about policy when we were talking about multi-factor authentication, and this helps to enforce best practices in terms of your network controls. You can put policies in place based on the rule to assign rules and to govern your Azure resources and your Azure resource groups and everything within that Azure environment, including your network. And assigning that policy then enforces compliance when creating new resources, as well as it will audit existing resources against that policy for compliance to allow you to make adjustments to remediate those resources to comply. And this can be regulatory compliance and what you need in terms of different regulatory requirements, as well as just your best practices within the organization. There are a lot of pre-built what they call initiatives, which is a group of policies that have those best practice and well architected rules within within the Azure policy uh, portal to that you can initiate and audit your total environment against these rules and make sure that you are protecting yourself based on best practices. And it's a very powerful tool from that standpoint because you don't need to understand and go through documentation for, say, if you're a healthcare provider for HIPAA, if you're a government entity, FedRAMP, you have all of that information already as a part of some of the initiatives that are within the Azure Policy Portal that you can enable very quickly and easily and audit your network and resources within that network of how you are utilizing those and determine then what you need to fix within your network to maintain compliance or to just to protect your environment properly. And all of this information then feeds into the Azure Security Center. And Azure Security Center is a provides you with a dashboard then that allows you to review all of those controls and review the network best practices excuse me, and review potential exposure to resources on your network. There's network maps that are within there, and all of the data that's collected from the from Azure Monitor and Log Analytics and Azure Policies all feed into the Azure Security Center, and that's where when we were talking about shared responsibility having all Azure Security Center is only as good as what you turn on and what capabilities you give it within your environment. If you don't turn on Monitor and turn on Azure Monitor within your environment, it's not going to feed back to you everything that you need to know. And Azure Security Center, when you go into it, go into Azure Security Center, if you don't have like monitoring agents on premise servers or on your virtual machines, it will actually tell you that as well. So it can help you to build that best practice infrastructure within your environment, as well as then also monitor your compliance in terms of your identity and role-based access control roles, and provides then again that central source for compliance and for protection of security as well as your network. The network maps are very helpful to understand where you might have ports open on virtual machines and things like that. And then to take it a step further now, we'll talk is Azure Sentinel. And many organizations have put into play those security infrastructure and event management systems or SIM systems. And what Azure Sentinel is the cloud native SIM that takes everything that is coming from log analytics and all of the threat intelligence that Microsoft has in play and starts bringing in the reporting and ability to investigate potential threats within your organization, and has the forensic capabilities to investigate and respond to threats. It can look at detect those threats based on anomalies within your environment and network sign-in issues that you may see in different anomalies in terms of who's trying to access your network that may be from an IP address that is not typical to your environment. And then you can investigate those and drill down into the network and into the resources to respond to those threats and remediate them if they need to be, or block them entirely. And the last piece to talk about here within this section of monitoring and managing in our architecture is how to securely manage our resources within our network. And there are times when, from a support staff standpoint, we need to access into an operating system of a virtual machine. And for Windows operating systems, these have typically been remote desktop services that have been used for those connections. And Linux operating systems, we've used SSH. Mistakes that have been made within a lot of organizations may be that in the past, not taking into account that the ports for RDP, which is 3389, and for SSH, which is port 22, have been left open to the internet. And this leaves a backdoor for uh, for a attacker to get in there. And it's very similar to if you were leaving the door to your car unlocked in a parking lot, where attackers know 3389 and 22 as prime ports to scan and to find and to attempt to find open access. In order to protect your organization from these attacks, these two services on the slide here uh, can be used together to protect against those open ports. And those are Bastion hosts and just-in-time virtual machine access. And from anyone that has done any type of server management in the past, you're familiar with the term probably jump box. And a jump box is utilized as that server that is isolated on a separate network that's used by support staff on outside networks to gain access into the network to manage virtual machines on the production network. It provides that extra layer of authentication that's needed to gain access to the production network. They may have their credentials as a support company or a support resource to get into that jump box, and then after they get into that jump box, they have to then re-authenticate to with a corporate authentication method to get into the production network. The Bastion host takes that jump box to a more secure level where it's now it's still on a separate VNet and a VNet subnet that is used to authenticate to those production resources. But the difference here is that you're not building a host on a operating system. You're strictly using that Bastion host. You're logging in there, and then you're doing your next step of login to get into the production network, and that decreases again that potential attack surface. And then, in addition to utilizing the Bastion host, just-in-time virtual machine access should also be used. And what just-in-time VM access does is, rather than leaving a inbound rule open for RDP or SSH ports to that virtual machine through the network security group, what this is doing is it's providing that just-in-time inbound rule that is temporary, that shuts down after an hour, and avoids the potential of somebody finding an open port scan and finding that port open and available to get into that virtual machine. All right. Now that we understand these services within Azure and how we would architect our Azure environment and protect and monitor our Azure environment and our resources both in the Azure environment as well as outside of the Azure environment in a hybrid network, let's talk about how we would bridge those connections and make those connections from the Azure environment to an on-premise network for a hybrid architecture. These connections, when we talk about them, primarily what is utilized are either a site-to-site VPN or an express route, and utilization of one or the other depends a lot on what your requirements are from a standpoint of an organization, the availability of applications and resources between on-premise and the Azure environment, as well as security and your requirements for private connections and security. And those the most popular is obviously and easiest to deploy is a site-to-site VPN. And we'll talk a minute about each one of these. So site-to-site VPN utilizes that virtual network gateway that we talked about before, either that or a Azure firewall or a virtual firewall appliance within the Azure environment to provide that connectivity, to provide that IPsec secure tunnel that is a site-to-site tunnel between the Azure environment and the on-premise network. It's an encrypted tunnel. It's secure, but it utilizes the current internet connection, the current ISP provider connection. It's using the public internet. It's providing that secure tunnel over that internet, but there is potential latency, potential performance issues that might be found within doing that, and you really don't have a bandwidth. You're a dedicated bandwidth scenario where you're going to be able to always say that I'm going to have X amount megabits per second or gigabits per second over that internet pipe, because based on what traffic your users or your environment is taking in terms of your overall internet provider connection is going to decrease from what you're going to have in terms of your gateway connection and your VPN connection. The one big benefit is setting up a site-to-site VPN from Azure to your on-premise network is very easy to do. It's not you need to create the endpoint connection within the Azure environment, and then do some configuration on your local router or firewall to get them to communicate, and then you're up and ready to go. So from a testing standpoint within the environment, to get something up and going quickly for proof of concept and things like that, site-to-site VPN is definitely the way to go, as well as from a failover and backup standpoint, site-to-site VPN can also be used. And that gets us then into, if your need for isolation and dedicated bandwidth, then we talk about ExpressRoute. And ExpressRoute is really something that you need to have for mission critical type applications. And it provides the isolation of the network, and as well as dedicated network bandwidth from the Azure environment to your on-premise network. Some key things around it is it takes more planning to implement, because you need to make sure your current ISP has the ability to provide you with that circuit, as well as then you need to order that circuit. And if anybody's ordered any circuits from a internet provider or your carrier, generally those take 30 to 45 days to get up and running. So if you aren't currently utilizing a co-located type data center with a provider that has a connection to ExpressRoute right in that data center, then what you need to do is create an order for that circuit and for that ExpressRoute with your ISP. So it's going to take a little while to get that up and going. And in the meantime, you could again use a site-to-site VPN and have that capability working there. Then the other connection piece, which is very helpful from a standpoint of a network, is the private link. And private links are very helpful for if you have a large on-premise database that you need to offload data that is maybe older data that is not needed to be accessed by your on-premise application to the database on a regular basis. You can use that private link, and that is a private endpoint that is connected directly to Azure. And it's a secure connection. It doesn't require an express route. It doesn't require gateways. It's exactly what it is. It's a private link into the environment, and very helpful, again, like I said, to utilize platform services and provide that connection from on-premise applications and databases to those platform services within the Azure environment. We've built now the foundation of everything. We've talked about all the services in Azure that can assist how we monitor and manage those services. So now how do we start to build our network architecture and build those best practices and tie all these resources and services in place to build an enterprise architecture. And in all organizations, we want to build the most secure and best architected network within the environment. We want it, and the key things to consider and keep into play here is what we're doing to isolate mission critical and confidential services from publicly accessed services and things like that. And what we do to do that is, and what's really important is the planning of that. Planning our connectivity, planning our security, planning our IP addressing schemes, our load balancing, our availability, our scaling, everything we've talked about for the last over an hour about taking all of those into account and architecting and defining all of that up front before we start to build out our services. Microsoft has created a very helpful framework around this, a couple actually that we're going to talk about in the next couple slides. The first of which is their cloud adoption framework, which is really a roadmap for how to start to adopt services. And for those of you on the call, I'll put these in the chat feature here towards the end. But what they do is what they've done is, from talking to industry experts and Microsoft experts, as well as their partners, they've built this framework now for how to begin to adopt cloud services in Azure. And it has a lot to do with what I was saying on the previous slide in defining what our outcomes are, doing that planning, what is our path, what is available and ready to go into the cloud, and then how are we going to adopt our cloud services, and what is our strategy for adopting those services. And then we take it a step further then and continue to govern and manage that all across all of that adoption process. And if you follow this framework, then you start to define and determine how you're going to bring workloads and bring services into Azure, and how you're going to build out that environment. And then when you start to build out that environment, now we start to look at the well-architected framework that Microsoft has to building out your environment within Azure. And there are 5 pillars to that architecture, and that's cost optimization, operational excellence, performance efficiency, reliability, and security. And we've talked about a lot of those things within this presentation thus far. When we talked about performance efficiency, we talked about scalability and availability. For reliability, same thing. A lot of the scalability and reliability and abilities and availability of resources, utilizing Azure Firewall or load balancing services for maintaining reliable connectivity and health monitoring of virtual machines for applications, and sending information and users only to those online virtual machines, provide that reliability. And then that security of having your isolation of your virtual networks and utilizing firewalls and network security groups to protect traffic and conditional access policies for making sure that devices and locations aren't risky and compromised to users. All of those come in there, and then operational excellence and cost optimization. We didn't talk a whole lot about cost within our discussion thus far, but Azure policy can help uh, to achieve that operational excellence, and utilizing Azure Security Center and Azure Sentinel can also help for maintaining that operational excellence and maintaining compliance to regulatory policies and things like that. From a cost optimization standpoint, how are we utilizing infrastructure services and platform services together to decrease costs and things like that? We haven't, that's a completely different discussion and presentation for another day, but we can do that, and we can take that into account in terms of how we're building out our availability sets and our scale sets as well. And as we talk about those well-architected frameworks, Microsoft has built the Azure Architecture Center, which has many well-architected best practice architectures, and kind of follow those architecture frameworks that have been vetted by different Azure professionals and partners and things like that to kind of give you that base framework for how you're going to build out your network. And that is really what should be your first step to building a network infrastructure on Azure. And again, as we finish up, I'll provide these links to everybody in the chat that is watching the chat. Otherwise, when you watch a recording, you can grab these links, very easily searchable within Microsoft Docs, to just do Azure Architecture Center, do Azure Well Architected Framework, do Microsoft Cloud Adoption Framework in Azure. Searching those on the web, you can very easily return those results and then find that information and utilize that information as you build your architecture within the Azure environment. Let's talk about a few of those scenarios here now. So right here is really what we were talking about when we were talking about a secure environment, a hybrid connection at its foundation and that also has that management capability. You can see when you're looking at this diagram, as we go across the diagram, we have our on-premise network. We have our gateway. We're looking at just a VPN gateway in this situation, where we have our route directly into a gateway subnet. And the key thing here is, as we talked about defining our virtual network and our VNets, this particular scenario has 5 different VNets on here. We have the 10.0, .255. We actually have 6 VNets on here, because we have the Azure Bastion subnet down here too, which is a 10.0.0. And then we have our firewall subnet. Then we have our web, business, and data. So as we isolate everything, you can see we have the web subnet here, which is going to have public traffic traversing, and we have a load balancer here that's now that is going to be publicly accessible and can route to the virtual machines. We have our business applications here, where our internal users are going to access, and then we have our database level here. Again, all these load balancers here that are balancing traffic between multiple virtual machines. And then down here, we have our Bastion subnet, which is our management access from our on-premise network into our environment to be able to manage our virtual machines. This takes it a step further, and this utilizes, rather than a Bastion subnet, which it is still utilizing a jump box, which tells me that this architecture framework was vetted and completed before the Azure Bastion was was available, which is completely possible because the general availability of Azure Bastion was just made available in previous few months. But if we were to replace this to Bastion subnet, that would be applicable here. We have here our gateways with a express route circuit to local and edge routers. And then we have, again, our express route gateway instead of a VPN gateway. And we have broken out again our web, business, and data tier into separate VNets and separate network security groups, keeping everything then protected. We can put route-based rules to only allow port 80 traffic into this load balancer, but we can block port 80 traffic from here, from the business tier and the data tier, therefore avoiding the potential attack surface of web traffic leaking into our business and production VNets and environment. And then the last one here is then the hybrid network with a VPN as well as utilizing Azure Stack. And we didn't talk a whole lot about Azure Stack just because this isn't a virtual machine type environment, but Azure Stack can actually extend the Azure environment into your on-premise environment by building and having a virtual network infrastructure within your own on-premise network that mirrors that of the Azure environment, and then provides a very similar management experience and deployment experience as it would to deploying resources within Azure. And you can see here, we have the on-premise network, we have the Azure Stack environment, and we are then utilizing the VPN gateway and between the Azure Stack into the site-to-site VPN tunnels and to the internet. And again, same with the on-premise network, is going through the internet and then also then can get into the Azure environment here. And in the Azure environment, in this particular scenario, we really only have we have two VNet setups here, VNets here, one the gateway subnet and the other the VNet that the virtual machines are on. So we don't have as much isolation as we did in the previous two scenarios, but we have really three different networks here set up in terms of our connection to our gateway, in terms of our hub and spoke type environment. And then we have our Bastion subnet here to get into the Azure environment as well. So the last thing I wanted to do real quick here was just kind of show everybody how quick and easy it is to set up a network within the Azure environment. And it's an ability and to get things up and running very quickly and to get yourself comfortable with the Azure environment. And if you go to portal.azure.com and you've never worked in Azure before, you can very easily set up a environment within Azure, set up a free account. Something else that you can do if you have a Skill Me Up account is there are a couple of challenges. The IaaS 101 challenge is very good for getting you started into how to create a virtual network, peer virtual network, and set up virtual machines and all of that. I recommend going and taking that challenge. But I wanted to show you real quick here. If I go to my resource group, let me go back here to resource groups, and I have a resource group already created here. And you can see here, I do have some resources in here. I've already created couple virtual networks, couple virtual network gateways. I'm going to add another virtual network in here real quick. And if you're in the marketplace and just do virtual network, very easily go to virtual network and create a virtual network. If you don't have a resource group, you can very easily create new. It's just putting a name in. I'm going to create a new virtual network. I go to my IP addressing, and here you can see, as I said, I've already set up two virtual networks here this morning, and those were 10.0 and 10.1. So you can see here, it automatically cycled my next IP address to 10.2. If I tried to make this say 10.1.10, well, it's going to say it's not valid, but you can see here, it also says that this IP address overlaps with 10.1.0. So what I want to do is make sure so that I can peer this, that I am staying in an a non-overlapping IP address space. So if you are doing your own IP address schema, you can very easily go in and create that IP address schema yourself. And it will tell you if you have overlapping address spaces right when you do it. Again, you have, we add a subnet in here, and I'm going to just name this demo sub, and give it a subnet address, and review and create. We'll go through this validation step. Creating a VNet doesn't take too long. It should be up and going in just a moment, but as I stated, I already created a couple here right off the bat. So as I stated, we did create we do have our virtual networks here, and these are isolated virtual networks. They're in two different regions, but what do we want to do? And my other virtual network has already been created. So now I have three virtual networks. So what do I want to do to get these connecting and communicating? What I need to do here is I want to peer these networks. Now, something about these two networks here is the virtual networks for VNet 2 and Net Gateway VNet both have gateways on them, just to take that into account. But if I go to peer and I want to peer my virtual networks, I'm going to peer now to this virtual network. Jesus. And I go in here and I enable, and you can see it enables the network access between the virtual networks from VNet 3 to my gateway VNet, as well as the other way around. If I only want to allow one-way traffic, I can very easily disable this, and that way I'm not going from my VNet to my cloud. What I really probably want to do is I want to allow VNet 3 to utilize the gateway for inbound traffic. So that would be, I want traffic to go from the gateway VNet to VNet 3, but I do not want it to go the other direction. And again, I want to enable traffic to be forward, and I want to allow, since I don't have any endpoints, it's not going to allow gateway transit right now. And so now I'm creating my peering. It's creating both ends of my peers, and it is going to then in a moment say that it is enabled and that my connections are available. So there we go. It's added the peering. It's updating. And in a moment, as we watch, peering has been completed and we are now connected. So making that connection and creating our virtual networks within our environment are very easy to accomplish within Azure. And getting up and running and isolating those networks are very important from a protection standpoint, as well as just maintaining and compartmentalizing what your workloads are and what your services are doing, help to create a architecture that then you have a lot of control over, rather than having it all spread over one virtual network and one network security group. You can then get very granular in the level you want to protect it within the environment. And let me, real quick, from one last thing before we finish up, is look at network security groups. Oops, the wrong one. And if we were to create a network security group and put it in my virtual network, it should only take a second to create that, and I'll show how you can very easily, again, look at the default rules and then create our rules within our network security group to control how everything has access. If we go to this resource, you can see that we have our VNet to VNet allowed, as far as inbound and outbound is always allowed as at the highest priority, and then same thing with load balancers from any destination. So we don't need to go in and create rules to allow these basic services to communicate with each other. If they had the VNets denied by default, when we peered a network, we would get a failure immediately. This allows that peering to take place without us having to adjust our rules. Same thing with a load balancer. If we put a load balancer in front of our virtual machines, internet traffic can already be allowed to traverse to that load balancer on that VNet. But if we wanted to then create more and different rules, we can then create those rules. We can say that they're only from certain IP addresses, like my own home network, and we allow only, port 3389 from that network. I'm the only one that needs access to that virtual machine. You can do that if you don't want to use just-in-time virtual machine access like we were talking about. You can set these rules, you can see very granularly. We can do it by here's application security group. So this is the ASG within the NSG. We can do any, again, IP address and port ranges. We can do, just TCP/IP. We can make a deny rule. And again, what's really important is this priority level. The lower the number is, the higher that priority. So it's going to be a parent structure based on what that number is in terms of what rule it's going to look at first and execute before it steps forward to the next rule. So hopefully that everybody has gotten something out of this discussion here today. I wanted to really get everybody comfortable with what the challenges are and practices are around architecting in an Azure network, how you think about availability and scalability and security within Azure, as well as hybrid networks, and then what those security services are and how you would architect for an Azure network and a hybrid network, and then provide some examples then for what you would look to do in terms of that enterprise network architecture, and how you would plan and isolate the networking within those environments to adhere to best practices and maintain a secure environment within Azure, as well as your on-premises type networks. So that ends our expert talk on best practice networking. I appreciate everybody's attendance, and my name is Dwayne Natwick. I will stay online for a few minutes if there are any questions. Thank you very much.